All right, so can everybody hear me? That's good. Welcome everybody to the RIMBAA Out of Cycle meeting. On behalf of Mohawk College, I'd like to say thank you for our guests for making the trek out to Hamilton. When I first read that I was supposed to present Everest, I thought again. But in reading the subtitle of the presentation, I thought maybe I could do something a little different than I normally do during my Everest presentations, and really talk about how we use it here at the college and in some of our projects to the extent that I can. And because we have some students here who've been using Everest, I thought maybe I'd start off with kind of a high-level 5,000-foot view of what you've been working with, because I'm sure you've been deep in the code and probably not been able to get a presentation on the larger architecture of Everest. And then I want to discuss some of the problems that we were seeking to solve with Everest, and then how we actually use those to bridge the gap between what we need to implement because of our projects and some internal resources that we've had. So that's what I'm going to be doing. Hopefully it's exciting enough for everybody. So a quick history lesson. College is doing applied research, and we start off as the Mark I, the Mohawk Applied Research Center in Health Informatics, and we started in 2007. And our goal was to prototype something called the Pan-Canadian EHRS Blueprint, which I'll get into later, but it's not a small project, and I think we naively went into it thinking, it'd be no problem. And we decided also that right or wrong we would use the standards prescribed by Canada Health Info, which means HL7V3, and we ran into issues. So when you look at the HILE, and this is my terribly drawn PowerPoint version of the HILE, I put shadows and a gradient on it, so it looks a little better. But it's about as pretty as PowerPoint can get. When you look at it, it kind of looks very simply like clients talk to some sort of bus, and then magical things happen, and then you get a response. But there's actually a lot of other systems that the HILE needs to integrate with. And because we were deciding to do it properly, not properly, but the way that was prescribed by Canada Health Info, we had to use HL7 version 3. And we quickly learned that, well, there's complex architectures at work here. Typically, when you want to send data between two systems, you'll have the system storing data in its own format. You need to somehow map that to a standard, serialize it, and send it across the wire where the reverse happens up the stack on the other system. And in V3, you use the RIM or RIM-like structures, and you graph it into something called an implementable technology specification, the ITS, which represents that on the wire so other systems know how to interpret it. And when we were looking at this originally, we had the parts in green, we had our internal data, but we had to do a lot of development with all the other stuff using raw XML serializers. And in 2007, a lot of the tools were clunky. In dealing with V3 XML, we tried Visual Studio 2005, didn't like the artifacts that were given to us, and a few of the other tools didn't like them. And also, the XML instances are, I'm going to use the word scary, because they're scary. They are. When you first look at them, they're scary. They're great for the electrical computers, but not good for your meat computer. And there's all kinds of nuances in the standard which are difficult to capture using the schema that were provided to us. And we had an additional problem in that we had a 4-month student turnaround. So every 4 months we'd get fresh bodies in, so we would start training on the V3 in XML, and then we'd have to restart every 4 months. So it was decided, primarily by myself and Dwayne, because we're kind of lazy engineers. Why are we doing this manual work over and over and over again? Why don't we just write a toolkit that we can give to students and they can use it to integrate? So mid-2008, we started Everest, and we had goals of abstracting the V3 XML. That was our primary goal, was trying to simplify how you interacted with V3. And it had to be well documented so students could learn as you type. One thing we noticed was students tend to skip large books of standards and just open up Visual Studio and try something, see if it works. No, it didn't work. Okay, try it. Learning through trying. And then we had to implement the data types and we had rules, and we had to provide validation and transmission to kind of abstract away the piping. And we had the first release in fall 2009. And when we first started this project, we had an SDO, Canada Health Infoway, and they released a series of artifacts for implementing V3. And this was 2007, 2008. And the ones that we had exposure to were the Visio files, because HL7v3 is represented as models called RMIMs, as well as the RIMBAA model. But the RMIMs were the ones that we were most focused on, because they're the easiest entry point. And the word views were documentation for those models. And they also gave us XSDs and something called a MIF file. And when you're trying to auto-generate code, you realize, again, VSDs and Visio files and documents are great for, again, your neat computer, but not good for computers to kind of read. So we ruled them out, and we focused first on XSDs. And we presented this a couple times, but using the V3 XSDs is tedious, and it's prone to errors, because schema, while it's good for representing structures that you can validate against, it's not really, doesn't lend itself to generating code from scratch, because it doesn't support things that V3 leverages very heavily, such as templated types or some of the more complex vocabularies. Because in V3 you can have nested vocabularies. If you want to stop me and ask questions at any time, just raise a hand. Yes?
Could you elaborate more on nested vocabularies?
Okay, so for example, I'm going to say nested vocabularies. Let's say hierarchical vocabularies. So for example, in nested? Okay, nested. Yeah. So for example, in V3, I'll take a simple example of null flavors. Right. So null flavor is a hierarchy where you can have a null flavor of other, which implies its parent. Right. So if you give me a null flavor of other, and then I say, is it no information? It is no information because it's other. But through that hierarchy, you can draw those relationships. Right? And XSD just gives you an enumerated list of values that you can have. So it's kind of hard when you're implementing that to implement those, because you have to do it by hand. Right?
So further on that, traditionally in IT, most people will represent codes as a two-dimensional table. Mm-hmm. What they went with very early in the V3 definition is the recognition that you almost had three dimensions, right? So that you had major groupings and then subgroupings within them, so that you could do analysis on this. This has further been expanded into things like SNOMED CT, where your code systems are no longer even hierarchical; they're network relationships, right? So one code can branch and can be representative of many grouping categories at once, and it's a definitive thing, right? So an example of that is the code for an appendectomy, which can fall under abdominal issues or surgeries or things like this, right? So these things, and they found that the necessity of doing this so that they can do back-end analysis and so forth. XSD comes nowhere near defining any of this. This is way beyond anything that they envisioned doing it with XSD. So a lot of the stuff that's necessary to be defined for understanding the context of a message can't be described in just an XSD.
So we crossed that off the list as well.
Yeah.
Basically, that's where I was going. We crossed it off the list because it wasn't suited. But there's these other files called MIF files, and whenever I say MIF, it's a format defined by 807 for exchanging models. It's called the model interchange format. So we decided to look at that as the perhaps only proper way of generating code for a pure V3 implementation. And we said, okay, how about we write a tool, and we call ours the general purpose MIF renderer, that can suck in the standard MIF files and then put them into a format that's a little more representative of an object-oriented programming language. So in a MIF file, there's things like a model, right? Well, we translate that. What would that be in a programming language? It would be a package or a namespace, right? And then there's classes inside of that with associations. We turn those into classes with properties, et cetera, et cetera. And then we run some optimization on them to get rid of duplicate types. Because in V3 you can, when you're defining a RMIM, you can clone types. So we clean those up. And then we render 4 different formats from that. We can do HTML, which are just documentation, C# assembly files, Java files, or this XSL and XSD. And we leverage 3 of these formats, the DLLs, JARs, and XSLTs, in our reference implementation, as well as in our partner projects, to actually implement V3. And when we were designing Everest, the code generation part is just one piece, right? We have kind of a component architecture in Everest where we said, okay, we can auto-generate a lot of things, structural things. We put validation and a little bit of intelligence in them. But really the core library is the data types. They have behaviors in them that we can't really auto-generate from MIF files. So we decided to write those by hand. Things like you can take an interval of time and then see if a timestamp lies within that interval. Right? That's a behavior that you can't really auto-generate. One of the glorious types of V3 is the GTS type. GTS type, everybody loves the GTS type. And it allows you to do things like Labor Day, right? It's not a specific day of the year. It's something that is described using sets. So we can put that kind of behavior into Everest to say, is this day in this set? And we can do at runtime some checks.
Yeah, and the sets get complicated. Like, so the classic example is take this drug 4 times a day for the first 2 days, and after that go down to 2 days, and then after a week take as needed.
Yeah.
You can say all of that in GTS in terms of the intervals.
Yeah. Yeah, you can also say, my favorite example is Labor Day. It's the first Monday of the first week of September. So you take all the Septembers, repeat them every year, and take the first weeks of September, repeat those every year, intersect them.
Is it the core data types library, the Pan-Canadian data types specifically, or did you cover like 2 versions of data types R1, data types R2?
So when we were developing this in 2000, this was about 2008, 2009, Data Types R2 project was underway.
Yeah.
So we decided, rather than writing 2 different data type libraries, for the most part, the data types, while they're represented slightly different, they kind of have the same behaviors, right? Like an interval is an interval, periodic interval is a periodic interval, even if they change the names. For example, the set expression in R1 is now the Q set in R2. So what we did is we provided kind of like a union of that functionality between the 2. So it encompasses R1 and R2 functionality, and you've actually brought up a good point, because that's how do we represent those on the wire. So let me just skip over this. We have what we call a formatter. And a formatter takes the data type, which is kind of that, it's not R1 or R2, it's hybrid, and then it actually is responsible for validating it and then representing it as data types R1 or R2.
And of course the Pan-Canadian
Or the Pan-Canadian
are a mix.
Yeah.
Yeah.
Yeah, and the way that we've designed the format architecture is you can combine XML ITS1 with data types R1 in Canadian mode if you're in Canada, or you can do XML ITS1 with data types R1, the universal mode for that if you're using IHE standards. Or CDA, exactly. And that's actually how the NHS has used the data types library, is they just fixed it to whatever their they wrote a formatter that represents the Everest data types as whatever their data type specification was. So that's the formatters, how we actually represent on the wire. And then we have what we call connectors, which actually connect these instances, the RMIM structures, to the wire. And we support queues, files, and the Windows Communication Foundation in .NET. And in Java, we support Spring and files if you want to connect out. So how does it all fit? Well, go back to that picture. We don't have to develop everything below canonical or the data model. We just have to map our data into what Everest can understand and then set it up. And most of Everest's development is lying in the app config file in .NET world, or the app context. And then you can figure how you want to represent that on the wire. And then it'll take care of both serialization, so as a client, and as a server as well. So it can operate in both modes. And just another view, here we have just a map of how that kind of tiered architecture would map to Everest components. So here's a C# example. All that translates down into RMIMs that you can instantiate. And then down at the bottom here, we have how you actually send it across the wire. So you just instantiate your object in memory, create a way to represent that on the wire, create something to connect it, and then send it over the wire. In Java, it's pretty much the same thing. We tried to keep them as equal as possible while not forcing Java developers into .NET patterns and practices and vice versa. Okay, and now this chart is the platforms that we support. So we have Java, which can operate in the client mode, so it can consume v3 services. We have .NET, which can act as a server. It can be integrated with BizTalk, or it can be used as a client. And then we have the Compact Edition, which is purely the client. And that leads into how do we actually use Everest in our projects, or in our lab, right? Because remember, we had that problem where we had to implement the Pan-Canadian EHR's blueprint. How do we actually, now that we wrote this thing, how do we actually use it? So the first thing that we did when we started talking, we said, oh, look, nobody has a shared health record. Let's do that first, because it seems challenging. For that, we needed a provider registry and a location registry and a client registry. And at the time, again, 2008, 2009, there was a provider registry. There was a couple client registries, but they were mostly IG, PICS managers. There was very little in terms of location registry, and there was no shared health record. So when we designed Everest, we said, okay, we have to be able to use this as a service provider. Right? We have to be able to use Everest to help write these stub systems so we can actually prototype how it would behave if there was a shared health record. So I don't want to get into this slide. This is kind of messy. But we came up with a service framework leveraging Everest, and we've used this in several projects. And we use Everest to host a WCF service. And let me just skip over this slide because I forgot to hide it. The reason we did that is in Everest, you can use a connector to send instances, but you can also tell the connector just to open up and listen, right, for a message. And you configure the security around it. But at its base level, you open up a server connector, and then you just say start, and then it raises events when it receives a v3 message that it understands. And then you can just access that object and do whatever you feel appropriate with it. So it was really flexible in how we leverage Everest, and we have 4 pieces of software running in our lab that have been prototyped on Everest, and these are live endpoints. You can actually hit these, and they'll respond to you with data. As a matter of fact, I think for most of our projects, we're using the PICS and PDQ v3 reference implementation of how to use Everest. The next way that we use Everest is interesting. In our HILE, the HILE is an enterprise service bus for routing. And it was a unique challenge in implementing the HILE because we had clients that were sending us V3 messages, and each V3 kind of interaction was structured slightly differently. A particular interaction might use, record target patient 1, another one might use record target patient 3, et cetera, et cetera. And we, again, being lazy, I didn't want to have to write onboarding or the on-ramping procedures over and over again. So for example, validating a client is the same regardless of what interaction you're sending. If you're sending up an observation or an allergy, if you want to validate the client, it's the same procedure. Why do I have to write different XPaths for the exact same procedure? So what we did is we wrote a BizTalk receive pipeline component using Everest. And we took GPMR, and inside the MIF files, whenever you derive an RMIM from a RIM, you have to tell, or there's a mapping back to where in the RIM this maps to. Right? So when you say record target in the control act, basically inside the MIF, it'll say, oh, this is a participation for a control act event. And what we said is, okay, how will we leverage that? We create some XSLTs, and we also use Everest for validation, and we write a BizTalk receive pipeline. So here's an example of a message that we might receive from a client, and I forget what 17CA is. I think that's an allergy. I can't quite remember. But you can see here, the V3 RIM does kind of show through where you have patient, which is an entity, playing a role in participating in an act. And what our pipeline component does is it takes that and it converts it into kind of like a RIM-ish ITS. We can't call it a RIM ITS because it's not actually a standard. We pitch this. It's 807.
Well, there is a RIM ITS standard.
There is. It's very close.
Okay, so but you're not following that.
Yeah, we're not following that because when we wrote this, it was prior to that.
Prior to what he had done.
Yeah.
Okay.
Yeah, but when Graham had, it was Graham that did that, right?
Yeah.
When Graham had sent that to me, and I looked at it and said, oh, that's pretty similar to what we're doing. I just didn't want to change it.
Yeah, projects that try to generate code off the XSDs soon get bogged down into hundreds and hundreds and hundreds of clone classes.
Mm-hmm.
Thousands.
Yeah, thousands, yes.
Yeah, and doing this, it allows us to, inside of BizTalk, when you add an XSD, it generates types. You have to input them into BizTalk. So basically, we just had to import the RIM XSD that is generated by GPMR. If we were following the RIM ITS, we'd import the RIM ITS XSD and then just translate it to and from that. But you can see now we have a player, which is an entity, playing a role, participating in an act. And it comes through quite nicely. And we're able to write generic XPaths now that query on the RIM rather than querying on instance messages. I did look at the RIM ITS. I've been meaning to go back and update this, but I haven't had the chance. Okay.
Well, I'm interested because I actually have to put the examples in there.
Oh, really?
For publishing.
Oh, okay. Well, do you want some examples?
Sure.
Okay. I've got thousands of them. I can just capture what's coming through our file.
Yeah, if we're close, I'd probably just write transform in.
Yeah, I think the biggest thing was the wrapper, in Graham's wrapper, the message tag, the root element, is just slightly different, but I believe the rest of the contents are pretty much identical. Because when I looked at his example instance, it seemed to translate one-to-one to what I've done, except for the root element.
Yeah. Actually, if you could send me some, that would be great.
Okay, yeah, I'll do that. And then we do the opposite for off-ramping. So once we get something on our bus, it's in RIM format or RIM-ish ITS format, we have to turn it back into an instance. So we also provide transforms for that.
So, an architecture that we followed at Alberta Health is the concept of an internal XML, proprietary XML format.
Yeah.
So, exposed beyond our boundaries, we communicate with HL7B3. Within our boundaries, it was often proprietary XML.
Something that's flattened or lighter weight or...
Yeah. On the prescribing dispensing project, we actually came up with this thing that we call pin XML, which mapped to the Java objects that were in the business layer.
Oh, okay.
Which were based on the V2, right? Because they had done the implementation. So we had to do the mapping from the V3 message into that object layer that looked very V2-ish.
Yeah.
And so we came up with this pin XML, which carried the semantics, and we put a translation there in the front.
Mm-hmm.
One of the advantages of that is, of course, size, heaviness.
Mm-hmm.
Disadvantage, of course, is that it's specific, right? So I mean, the pin XML wouldn't work for the client project, right? You know, and so it's a one-off.
Yeah. We did the same thing our first 2 revisions of our reference implementation. We did custom canonical forms.
Okay.
And then for our third one, we have a unique environment because any company can come to us with a client registry and say, we'd like to see how it plays. So we always had to do this, go back, modify the transforms to and from the client registry. So that's why we chose in the third version of our EHRS prototype to do the RIM as our canonical form. So the RIM ITS is our canonical form inside of the bus.
So based on experience then, how heavy is it in comparison?
Oh, for the transforms or for...
Well, no. I mean, the transforms are going to be what sort of, because there's going to be nuances and everything. But how heavy is the RIM ITS? I mean, one of the problems is with the general serialization, the plain ordinary ITS is and this, we'll get to this when we talk about fire. The complaint is I had 7 data items. And
you need 16 megabytes of
wrapper
for
XML in order to send it.
Yeah.
Does the RIM reduce that?
It the way that we have it set up is it doesn't, but because it's in the RIM, you can kind of trim off relationships you don't need. It's easier to find them. Typically, what we found is once you're inside the bus in the canonical form, it's really only the orchestration, the orchestrator that's going to be using the RIM ITS, and then we off-ramp. So if we have a client registry speaking v3, by the time it hits that endpoint to go off to the client registry, it's in v3, or if it's v2, it'll be transformed into v2. So the v2 is what goes to the external system. Inside the bus, we use RIM because it made our lives a little easier with doing like the XPath and BizTalk.
Okay.
But to answer your question, it is still heavy. It's just, it doesn't look as, well, it looks more confusing, but it's easier to process from a computer standpoint. Okay, so that's all the boring stuff. So how to use Everest on the client side, which is the exciting parts. Now, in prototyping an infrastructure, as with any infrastructure project, the problem that you get is people come up to you and say, what do you guys do? You sit in this room and code for 3 years, and what have you really done? I don't see anything. I can't touch it. All you show me is these XML interfaces. That's kind of boring. And we have the visualizer tool to kind of illustrate the infrastructure, but people like to see, or they can't see the potential of a system unless you give them some sort of user interface to say, this is how we could expose this data. And we've used Everest on the client to do that. And one of the apps that we wrote, one of the first apps that we wrote with Everest was a tabletop computer app that would reach out to a location registry and map data points on a map. Also, we have another app that a student here is demonstrating to contact the provider and client registries. And I'm sorry for the choppy video, I'm recording the screen as it's playing. But basically what would happen is it would actually reach out to our Heil infrastructure, contact the client registry and provider registry to get names and addresses, and then it would present what comes out of the longitudinal record service as one continuous profile on the tabletop computer. And one of the demos here that he's going to show is the ability to plot different data points that are the same type of observation from various hospitals that are using the same equipment. Right? So if it's a spirometry reading over time, you can plot that, and it's kind of a contrived app to kind of show what's the use of a longitudinal record service. Why do you even want a Heil? What's the point in sharing this data? And another thing we've done with Everest is a Windows Phone app, and I showed this in January at the working group meeting. But you can actually, again, using V3 and Everest, you can kind of come up with a compelling user interface of why would you even want infrastructure with rich data like V3, and it shows that you can do things like plot locations, or you can trend data. And Everest basically takes away the pain of dealing with this ugly XML. Not that it's super simple, but it's easier than dealing with the raw XML. And also, in Everest, we can actually do, these are Pan-Canadian standards messages, but the previous request was to a PDQ supplier. So one of the things we did is we prototyped integrating an IHE PICS manager and PDQ supplier with the Canadian standard shared health record. And that was another reason why we had to write our own PICS manager, was to speak the V3 standards as well. So for more information, we have everest.mark-hi.ca. We've had about 4,600 downloads of it so far. And also we have a public SVN where you can grab the latest source code. We don't allow commits unless you email me and ask nicely. Or if you're a student at Mohawk College, you can commit things and then I'll reject them. Okay, any questions?
Do you know how many downloads have you had at Everest? Do you know where it's being used?
Yeah, Everest is currently being used in the NHS CDA API, the .NET version.
That's the UK National Health Service. Yeah.
Yeah. So they were in contact with us to actually get some, support about, how do you do this or how do you represent this. There's been several students from China who've emailed me. I'm not sure what they're doing with it, but they've downloaded it. We've had quite a few downloads from India. When I look at the download logs, they're from companies like Tata. So again, I don't know what they're doing with it, but they've grabbed it.
Do you know
And
any of the jurisdictional implementations are using it in their libraries?
In Canada?
Yeah.
In Canada, we started Everest in 2008, 2009, and Canada Health Infoway used Everest to go and acquire the MBT, which is slightly different than Everest. And then because Canada Health Infoway developed MBT and provides funding and support for implementing MBT, a lot of people choose to use MBT. However, Canada Health Infoway will mention Everest as well as an alternative. We mainly focus on the UV spec now because the MBT seems to have the Canadian market pretty much wrapped up.
I actually don't know if I
Oh, really? Oh, okay. Yeah, but that's news to me.
I know Infoway is pushing it strong.
Mm-hmm.
But were they using it in Alberta?
They were trying to. It's still a somewhat immature product, shall we say?
Mm-hmm.
Yeah, I'm working with them. They are trying to push it to
Yes.
Alberta and Saskatchewan. Right
Yeah, and actually,
What are they doing
I
in
would
Saskatchewan?
say that the
I
success.
don't know. I literally started working on a project today
Okay.
to see what the new
I would
pieces
say
are.
the success in Alberta has been very much mixed at this stage.
So when I was at Infoway, I'm sorry that you have to hear this, but a lot of this is tied to politics.
Do you want me to turn off the camera?
No. I won't
I
say
can
anything
edit this out.
inappropriate.
I'll just leave this out.
There was incentive money that was provided to Infoway to encourage products.
Right, we're aware of that.
Okay. Well, it was it was part of the national budgets and everything